Hello everyone, this is teacher Rejil. This video is on factor theorem and our competency here is prove the factor theorem. This is the statement of the factor theorem. The binomial of the form x minus c is a factor of the polynomial p of x if and only if p of c equals 0. Before we are going to prove this theorem, we will recall first dividing a polynomial p of x by a binomial of the form x minus c. Specifically, we will be dividing 3x squared plus 2x minus 5 by a binomial of the form x minus c, which is x minus 1. So this is how we set it up. 3x squared plus 2x minus 5 on the inside and x minus 1 on the outside. Step 1, divide the first term on the inside, 3x squared, by the first term on the outside, x. So 3x squared divided by x is 3x, then multiply back. 3x times x is 3x squared. Then 3x times negative 1 is a negative 3x. Then after that, we subtract. This means 3x squared plus 2x minus the quantity 3x squared minus 3x. That gives us 5x. Then we are going to bring the next term down, which is minus 5. Again, the first term on the inside divided by the first term on the outside. That's 5x divided by x. That's positive 5. 5 times x is 5x. 5 times negative 1 is negative 5. Then again, subtract 5x minus 5 minus the quantity 5x minus 5. That gives us 0. This means the binomial 3x squared plus 2x minus 5 can be written as 3x plus 5, which is our quotient, times our divisor, which is x minus 1, then plus our remainder, which is 0. So this 3x squared plus 2x minus 5 is our p of x. Our 3x plus 5 here is our quotient. And x minus 1 here is our divisor of the form x minus c, and the 0 here is our remainder. We need this math statement in proving the factor theorem. Actually, there are two parts of this proof. Okay, the first part is if p of c equals 0, then x minus c is a factor of p of x. That's the first part. Why do we have two parts here? Because of this line, if and only if. The second part is we are going to prove that if the binomial x minus c is a factor of the polynomial p of x, then p of c equals 0. Now let's start the proof of part 1. This was the math statement that we obtained a while ago. P of x equals q times the binomial of the form x minus c, or x minus c plus r. We know that from remainder theorem that r is actually p of c. So we can replace this r with p of c. And from our statement here, p of c is 0, so we can replace this p of c with 0. And because we have here plus 0, so we may not include that one, so we come up with p of x equals q times x minus c. Now we have proven the first part. Let's prove the second part. Okay, we will start with this equation, p of x equals q times the quantity x minus c. We have this equation. We are going to evaluate the polynomial at c. So we need to say we will just replace all our x's here with c. So it becomes p of c equals q times the quantity c minus c. So we know that c minus c is 0. So we can replace that c minus c with 0. And then we know also that q times 0 is 0. So we have already proven part 2. The factor theorem actually will answer the question, is a binomial of the form x minus c a factor of a given polynomial? Or here specifically in our example 1, is x minus 2 a factor of p of x equals x squared plus 3x minus 4? So how do we know? Okay, by factor theorem, we are just actually evaluating the polynomial at c equals 2. Our binomial divisor here is x minus 2, so our c is 2. So we replace all our x's here with 2. We get this. Now we can simplify furthermore. 2 squared is 4, 3 times 2 is 6, then minus 4. And 4 plus 6 minus 4 is 6. So the remainder, or the value of the polynomial at c equals 2 is not 0. So therefore, x minus 2 is not a factor of the polynomial p of x equals x squared plus 3x minus 4. Let's do another example. Is x plus 1 a factor of p of x equals 2x squared minus x minus 3? So we will evaluate the polynomial at c equals negative 1. We have here our binomial divisor x plus 1, meaning to say our c here is negative 1. So we replace all the x's with negative 1. So we have p of negative 1 equals 2 times negative 1 squared minus negative 1 minus 3. So we can simplify furthermore. So 2 times negative 1 squared is 2. Okay, minus negative 1 is plus 1, then minus 3. 2 plus 1 is 3, minus 3 is 0. So the value of the polynomial at c equals negative 1 is 0. So it means to say x plus 1 is a factor of 2x squared minus x minus 3. I prepared here 4 items for you to work on. You can pause the video and try answering these 4 items. Use the factor theorem to determine whether the binomial of the form x minus c is a factor of the polynomial p of x. I will now show you the answer. For item number 1, it's a yes, because the value of the polynomial at x equals negative 1 is 0. Number 2, at x equals 2, the value is 1, so it's a no. Number 3, at x equals 3, the value of the polynomial is 0, so it's a yes. Item number 4, at x equals negative 3, the value of the polynomial is negative 1, so it's a no. Did you get all the items right? I hope you did. Thanks for watching, guys. This is Teacher Rejil. Keep safe.